Okay, Assalamualaikum and a very good day to my students. Okay, so welcome to today's class. And for today's class, we're going to look into the first chapter, okay, chapter 1 variation. And for this class, we're going to look at the first subtopic 1.1 direct variation. Okay, in this chapter, you will learn about three types of variation. Okay, the first one is direct variation, the second one is inverse variation, and the third one is combined variation. And for the purpose of today's class, we only look at the first part first. Okay, so 1.1 direct variation. Okay, so in today's class, okay, the learning standard is, okay, explain the meaning of direct variation. Okay, what is the meaning of direct variation? Okay, so we know that direct variation, okay, is actually explain the relation between two variables, okay, such that when the variables y increase, then the variable x also increase at the same rate and vice versa. This relation can be written as y varies directly as x. Okay, so we look at the first example. The total wage of part-time worker as a promoter varies directly. Okay, so here it mentioned that varies directly as the number of hours he works. State the change on A, the total wage if the number of working hours is double. Okay, so we know that from this definition, okay, if y increase, then x also increase. So what can we do here? Okay, so if the total wage, if what happened to the wage if the total number of working hours is double? So if the number of working hours is double, so we know that the total wage is also double. Okay. B, the total wage if the number of working hours increase by 40%. Okay, we know that the increase is the same. Okay, so if the working hours is decreased by 40%, so we know that the total wage also decrease by 40%. Okay, and C, the number of working hours, okay, if the total wage is half. So we know that if the total wage is half, okay, the number of working hour is also half. Okay. Okay, so let's look at the first self-practice 1.1a. Okay, the value of resistance of a wire varies directly as its temperature. State the change on the value of resistance if the temperature increased by 10%. Okay, so if the temperature increases by 10%, we know that the value of resistance will also increases by 10%. Okay, B, set the change on the value of resistance if the temperature decreased by half. So if the temperature decreased by half, so we know that the value of resistance will also decreases by half. C. State the change on the temperature if the value of the resistance decreased by 1/4. Okay, so we know that the temperature will also decreases by 1/4. Okay. Okay, next, number 2. Puan Wardina wants to buy green beans selling at RMX per kilogram. State the price if Puan Wardina buys 500 gram of green beans. Okay. So we know that RMX is for 1 kilogram. So 500 gram is actually half of 1 kilogram. So what happened to the price? Okay, so the price decreases half of RMX per kilogram. Okay, and then B. Puan Wardina buys 2 kilogram of green beans. So 2 kilogram is actually double from the question, right? Okay, so we know that the price will increases 2 times of RMX per kilogram. Okay, so I hope it clear for you. Okay, next, number 3. Okay, the table below shows the relation between the time needed and the number of bottles of jam produced in a factory. So we can see time. There are 5 minutes, 10 minutes, 15 minutes, 20 minutes, and 25 minutes. Okay, state the change in the number of bottles of jam produced when the time is double. Okay, for example, 5 double, we get 10. So from 10, we will get 20. So we can see it's double, right? And then if 10 minutes we double, we will get 20. So from 20, we will get 40. It's also double. Okay, so what when we say for the first situation? Okay, the number of bottles of jam is double. Okay, and B, the times is half. Okay, so we know that if the time is half, the number of bottles also will half. Okay, so we can say that the number of bottles of jam is half. Okay, so I think this is for the first part. Okay, now we continue with the next learning standard. Okay, for the next learning standard, okay, students should know how to determine the relation between two variables for a direct variation. So we will know, okay, what is the relation between two variables for a direct variation. Okay, so look at this part. Okay, for a direct variation, y varies directly as x can be written as, okay, in the variation relation, okay, you can write it like this. Okay, and then if we convert it to the equation form, it will become y equals to kx. Okay, where k is a constant. Okay, when you look at this part, okay, first you have y, okay, varies directly as x. Okay, when you change this form into the equation form, okay, look what will happen. Y, okay, this symbol will become equal, and then x. And then you must always remember that there will exist this constant. Okay, so y equals to k x. So each time when you convert the variation relation into the equation form, you must know that there will be another constant, k. Okay? Okay, look at example 2. A toy car moves from a state of rest. The distance traveled by the toy car y changes with time t, as shown in the table below. So we have time, okay, and distance. Okay, and the question asked, determine whether y varies directly as t or t square. Hence, write the relation in the form of variation. Okay, so what can we do first? Okay, so we write down the table. So we have t, we have y. And then the question asks, okay, determine whether y varies directly as t or t square. Okay, in order to get whether it varies directly as t or t square, okay, what you must do, okay, y we divide with t, okay, and the second one, y divide by t square. Okay, t equals to 2, 4, 6, 8, 10, 12. Y is 14, 28, 42, 56, 70, 84. So y divide by t. So 14 divided by 2, we will get 7. Okay, 28 divided by 4, we will also get 7. 42 divided by 6, also 7. 56 divided by 8, also 7. 70 divided by 10, also 7. 84 divided by 12, also 7. Okay, next we try to divide y divided by t square. Okay, so what happened when 14 divided by 2 square? So you will get 3.5. Okay, 3.50. Okay, so let's try the second one. So 28 divided by 4 square, you will get 1.75. 42 divided by 6 square, 1.17. Okay, 56 divided by 8 square, 0.88. 70 divided by 10 square, 0.70. And finally, 84 divided by 12 square, you will get 0.58. Okay, so from this value, okay, what can you say? Okay, we can see that, okay, y varies directly as t because of the value of y divided by t, or y over t, is a constant. So, okay, hence y is varies directly as t. Whereas, okay, we can see that y does not vary directly as t square because y over t square is not a constant. Okay, so I hope you understand this example. Okay, so let's look at example 3. Okay, by drawing the graph of y against x, determine whether y varies directly as x. Okay, so okay, we try to draw a graph. Okay, y-axis and x-axis. Okay, so we have 0, 0.5, 1.0, 0.5, 2.0 and 2.5. Okay, and for what this is for y-axis, and then for x-axis we have 2, 4, 6, 8, 10. Okay, 0.2, 0.4, 0.6, 0.8, 1.0 and 1.2. Okay, so we try to plot. So we have 0.4 and 1.5. Okay, over here. Then we have 0.8 and 2.0. Okay, and finally 1.2 and 2.5. Okay, we try to draw a straight line. Okay, as close as that. Okay, okay, so from this graph, okay, we can see that the straight line does not pass through origin. It intersects y-axis at 1. Okay, if this happen, okay, what can we conclude? Okay, we can conclude that, okay, hence y does not vary directly as x. Okay, so next, B. By drawing the graph of y against x square, determine whether y varies directly as x square. Okay, so for this part, okay, I want you to do it yourself. Okay, if the straight line you obtain later, okay, passes through the origin 0, 0, so you can conclude that y varies directly as x square. If not, okay, it does not vary directly as x square. Okay, so this part I want you to try it yourself. Okay, B. Okay, next we look at example 4. Okay, it is given that m equals to 0.8 and n equals to 0.125. Okay, express m in terms of n if, okay, so the first part, it is given that m varies directly as n. Okay, so we know that, okay, from this, okay, we know that it is a variation relation form. Okay, so from this form we need to transform it into equation form. Okay, so what can we do? Okay, first m is equals to n, and then we must put the constant k. Okay, don't forget. Okay, so we already get the equation form. Okay, what can we do next? Okay, from the question, it is given m and n values, is it? Okay, so first you substitute these two values, m and n, in order to get the value of k. Okay, so m is 0.8 equals to k, n is 0.125. Okay, so k is equals to 0.8 divided by 0.125, and we will get k is equals to 6.4. Okay, so when we get the value of k, then we just substitute it into the equation. So the final answer is m equals to 6.4 k. Okay, clear? It's quite simple, right? Okay, next B. Okay, m varies directly as the cube of n. So we know that as the cube root of n. So we know that cube root of n is k. This is cube root of n. Okay, so we transform this relation into equation form. So we get m equals to k cube root of n. So next we need to find the value of k. So we substitute the value of m and n. So 0.8 is equals to k cube root of 0.125. Okay, so you will get the value of k is 1.6. So the final answer is m equals to 1.6 cube root of n. Okay, any problems so far? I hope you get along with me. It is not that hard yet. Okay. Okay, let's proceed to example 5. Okay, the extension of a spring X varies directly. Okay, highlight this word. Okay, varies directly as the mass of the load W gram hanging on the string. It is given the extension of the spring is 3 cm with a load of 200 gram is hung on the string. Express X in terms of W. Okay, so we write the relation first. Okay, so we know that X varies directly as the load W. Okay, and then we change this form into equation form. So X is equals to KW. Okay, next step, we need to find the value of K. So substitute the values of X and W given from the question. So X from the question is 3 equals to K. W, the weight is 200 gram. So K is equals to 3 divided by 200. So we will get 0.015. Then substitute the value of K into the equation. So finally, the answer is X is equals to 0.015 W. Okay, that's it. Okay, we proceed with example 6. Okay, it is given that y varies directly as x. Okay, if y equals to 0.14 when x equals to 0.2, calculate the value of y when x equals to 5. Okay, So first, okay, you try to write this relation, okay. We know that y is varies directly as x. Okay, then change this form into equation form. Y is equals to kx. Then we know we need to find the value of k. Okay, so from these two information, substitute it into this equation. So 0.14 is equals to kx is 0.2. So k is equals to 0.14 divided by 0.2. Okay, and you will get 0.7. So we know that y is equals to 0.7 x. Okay, so what is the value of y when x equals to 5? Okay, so A. So y is equals to 0.7 when x equals to 5, substitute it into the equation. So 0.7 times 5 is 3.5. Okay, and then B. X when y equals to 0.875. Okay, so we know that y is equals to 0.7x. Okay, y given is 0.875 equals to 0.7x. Okay, so x is equals to 0.875 divided by 0.7. Okay, and our final answer is 1.25. Okay, I hope so far you can understand. Okay, next example 7. Okay, the area L centimeter square of a semicircle varies directly as the square of its diameter d. It is given that the area of the semicircle is 3.08 cm square when the diameter is 2.8 cm. Calculate the value of d. Okay, this d, okay, when L area, okay, is 19.25. Okay, so first, okay, from this question we know that, okay, the area varies directly as the square of its diameter. Okay, so area is L, is varies directly as the square of its diameter. So diameter is d and you square it. Okay, so from this relation, change it into equation form. L is equals to kd square. Okay, and then you need to find the value of k from the given information from the question. Okay, so from the question, okay, given that L is 3.08, okay, when diameter is 2.8 square. Okay, so here, okay, calculate the value of k. K is equals to 3.08 divided by 2.8 square. So you will get k is equals to 11 over 28. So we know that L is equals to 11 over 28 d square. Okay, so from the question, okay, when L is equals to 19.25, so what is the value of d? Okay, so we use this equation. So 19.25 is equals to 11 over 28 d square. Okay, so how to find d square? So 28, we move to the next side, so you get 19.25, okay, times 28 divided by 11. Okay, so d Okay, press the calculator. What is this value? Okay, so when you press the calculator, you will get 49. Okay, so the value of D is square root of 49. So you will get 7 centimeter. Okay, so actually this type of question, there is another alternative method where you can use the concept of proportion. Okay, so I want you to look at your textbook, and there is the alternative method shown there. Okay, you can look it yourself. Okay. Okay, finally, example 8. Okay. Okay, the period of oscillation A seconds of a simple pendulum varies. I try to highlight it. Varies directly as the square root of the length of its string. Okay, so we know that the period of oscillation A, okay, is varies directly as the square root of the length of its string P. So this is the relation that you get. Okay, so convert it to equation form. So A is equals to K square root of P. Okay, so now we know that we need to find the value of K first. Okay, so substitute the value of A and P that you get from the question. Okay, so A is 1.2 second equals to K square root of P is 9. Okay, so K is equals to 1.2 square root of 9 is 3. So 1.2 divided by 3 is 0.4. Okay, so hence we know that A is equals to 0.4 square root of P. Okay, so when we know that when P, okay, is equals to 25, okay, this 25, okay, calculate the period of oscillation A if the length of the string is 25. Okay, so we know that A is equals to 0.4, the square root of P is 25. So you press the calculator and you will get 2 seconds. Okay, also this example also can be solved by using the alternative method, which is using the concept of proportion. Okay, and you can try it later. Okay. Okay, so for the self-practice 1.1b, okay, so I want you to do it yourself. Okay, so number 1 AB, number 2, number 3, 4, 5, 6, 7, 8, 9. Okay, that's it. Okay, until number 9. Okay, I want you to do all these 9 questions. Okay, and you submit it in the Google Classroom. Okay, so later I will assign this question to each and every one of you. Okay, and then make sure in 1 week time, okay, you finish this 9 question and you can scan or snap your answer and upload it in Google Classroom. Okay, so if you have any question, any problem, okay, you can just WhatsApp me in the WhatsApp group. Okay. Okay. Okay, now we proceed to the next learning standard. Okay, in this learning standard, okay, you must know how to determine the relation between 3 or more variables for a given joint variation. Okay, so what is a joint variation? Okay, what is a joint variation? So from the previous example, you know that you only have 1-to-1 relation, right? Okay, now, we know that, the definition for joint variation. Okay, for a joint variation, y varies jointly as x power of m and z power of n. Okay, it varies more than 1. Okay, so look at here. Okay, y varies directly as x power of m, z power of n. This is the variation relation form. Okay, if you convert it to the equation form, the same thing like the previous one. Okay, this symbol you will change into equal, and then there is a constant k. Okay, so we look at the first example. Okay, P varies, P varies directly as Q and square root of R. Okay, that's it. Okay, and then equation form is P is equals to KQ square root of R. Okay, B, y varies directly as the square of w, so w square, and cube of x, so it is x cube. Okay, change it into equation form. It will be y equals to kw square x cube. That's it. Okay. C, the volume of a prism V varies directly as the area of a cross section A and its height h. Okay, so in the equation form, V is equals to KAH. Okay, finally D, the mass W of a cylindrical metal rod varies directly as its length P and the square of diameter D. So D square. So we change it into the equation form. W is equals to K PD square. Okay, as simple as that. Okay, we look at the next example. Given that x varies directly as y square z, okay, express x in terms of y, and z if x equals to 6 when y equals to 3 and z equals to 5. Okay, so I write it first. Okay, x varies directly as y square z. Okay, change it into equation form. X is equals to ky square z. Then, like the previous one, okay, we need to find the value of k first. Okay, by substitute the given value of x, y, and z. Okay, so x is 6 equals to k, y is 3 square, z is 5. Okay, from this value, you can get k is equals to 6 divided by 3 square, 5. So k is equals to 2 over 15. Okay, so the answer is x is equals to 2 over 15 y square z. Okay. Okay, next example 11. The gravitational potential energy E joules of an object varies directly as its mass mkg. The gravitational acceleration, okay, and its position at a height of h meter from the ground. Given that E equals to 197 joules when m equals to 4 kg, g equals to 9.81 and h equals to 5 meter. Write an equation that relates E, m, g, h. Okay, so we know that E varies directly as m, g, h. Okay, so we change it into equation form. So E is equals to constant k, m, g, h. Okay, next find the value of k. Okay, by substitute the values of E, M, G, H given in the question. Okay, so from the question, E is 197 equals to K, M is 4, G is 9.81, H is 5. Okay, so K is equals to, okay, you calculate, you will get 1. Okay, so we know that E, okay, is equals to mgh. Okay, where is the K? The K is 1. Okay. Okay, next, example 12. Okay, three quantities STU vary as shown in the table on the right. It is given that S varies directly as T and the cube root of U. Cube root, okay, of U. Calculate the value of X and Y. Okay. So change this relation into equation form. Okay, so S is equals to K T cube root of U. Okay, then you use the information from this first column, okay, in order to get the value of K. Okay, so S is 6 equals to K, T is 0.8, and cube root of 27. Okay, so you calculate, you press your calculator. So K, you will get 2.5. Okay, so okay, hence we know that S is equals to 2.5 T cube root of U. Okay, so next, okay, we want to find the value of X. Okay, so by using this formula, so S is equals to 2.5 T cube root of U. Okay, so S is actually X. Okay, so X is equals to 2.5, T is 1.2, cube root of 125. Okay, so press your calculator. So you will get the value of X is 15. Okay, the same goes to Y. Okay, so S equals to 50 is equals to 2.5, T is 40, and cube root of Y. Okay, so cube root of Y, okay, you press your calculator, you will get 0.5. Okay, so to get the value of Y, so you need to cube both sides. Okay, so 0.5 cube, you will get 0.125. Okay, so I hope my explanation is clear. So if you have any problem, you can just rewind this video and try to understand and look back one by one. Okay. Okay, so for the self-practice 1.1c, okay, I want you to do it by yourself and submit it into the Google Classroom later. Okay, so you have to do number 1, number 2, number 3, number 4, number 5, number 6, number 7, and number 8. Okay, I think for each of the question, okay, the problem is just the same like the example. Okay, so you can refer back to the example, okay, in order to answer this self-practice 1.1c. Okay, we move to the next learning standard. Okay, solve problem involving direct variation. Okay, So look at example 3. Okay, Charles Low stated that for a fixed mass of gas, the volume V centimeter cube of the gas is directly proportional to its absolute temperature T Kelvin if the pressure of the gas is fixed. It is given that a container of 30 centimeter cube of gas at a temperature of 30 degrees Celsius. Okay, A, express V in terms of T, and B, calculate the volume in centimeter cube of the gas if the temperature changes to negative 11 degrees Celsius. Okay, so how to solve this problem? Okay, so first of all, okay, we need to understand the problem. Okay, from the problem, okay, it is given that V is directly proportional to T. Okay, and from the question itself, okay, we know that, okay, when V is equals to 30, okay, sorry, V is equals to 30 when, okay, T is equals to, okay, 273 plus X Kelvin. Okay, this is the conversion. Okay, you need to know that. Okay, next. Okay, we need to have a strategy. Okay, so devising a strategy. Okay, first, okay, what we need to do? Okay, so first we need to, okay, write the direct variation in the form of equation. Okay, this is the first thing that we need to do. Okay, the second one, okay, substitute the value of T into the equation and hence calculate the volume of the gas. Okay, okay, the third one, okay, the third part, okay, we implement our strategy. Implementing strategy. Okay, so we know that, okay, we have V is directly proportional to T. Okay, so we also know that, okay, V is equals to KT. Okay, where our T is actually 273 plus X. Okay, so from the question, okay, V is equals to 30. Okay, this part 30. Okay, so 30 is equals to K 273 plus 30 degrees Celsius. Okay, so K 30 divided by 303, and we will get 10/101. 1. So we can conclude that V is equals to 10 over 101 T. Okay, so settle part A. Okay, then B. Okay, calculate the volume in centimeter cube of the gas if the temperature changes to negative 11 degrees Celsius. Okay, so V is equals to 10 over 101 273 minus 11. So V is equals to 225.9 for centimeter cube. Okay, and our final strategy, okay, is making a conclusion, where the answer of the first part is V is equals to 10 over 101T, and the answer of the second part is V is equals to 25.94 centimeter cube. Okay, so this is actually step by step. Okay, what you need to do in order to solve this problem involving direct variation. Okay. Okay, so for example 14, okay, I want you to try yourself, okay, with the same strategy. Okay, if you follow step by step, okay, I think you will easily get the answer without any problem. Okay, so next same goes with the self-practice 1.1D. Okay, I want you to do number 1, number 2 and number 3. Okay, so for this class you have 3 assignment. Okay, so self-practice 1.1B, 1.1C and 1.1D. So you have 1 week time, okay, to finish all this question, okay, and submit it to me in Google Classroom. Okay, so if you have any problem, okay, during your the process of finishing this assignment, you can just WhatsApp me. Okay, as usual, no problem. Okay, I will try to help you. Okay, so that's all for this class. So we have finished the first part, okay, 1.1. Okay, 1.1 direct variation. Okay, so for the next class we will look into inverse variation. Okay, so that's it for today. So thank you very much. Okay, don't forget to fill in your attendance form. Okay, bye, see you next class.